Hello, lovely people. What is up? Today we are solving Leetcode problem number 1009, complement of base 10 integer. So the complement of an integer basically is the integer we get when we flip all the zeros to ones and ones to zeros. So basically when we are given a number in decimal format, we convert it to binary and then invert all the zeros and ones. So we are asked to return such a decimal represented integer, that is the complement of the given integer n. The problem here is every integer number is represented in 32 bits, which, for example, let us take the number 2. The binary representation is a bunch of zeros on the front and then 0, 1, 0. So instead of flipping infinite bits, we only flip the bits that exist in the number's binary representation. So instead of converting the number into a binary string and then flipping it, we can process each bit directly using bit operations. Here, we should also remember another very important concept, that each place of a binary number can be represented by the power of 2. So more specifically, all the places that have a 1 has 2 power the position, since it is 1. So what we can do is we can use this particular concept to our advantage. So instead of flipping the whole binary string, the algorithm can do something that's very smart. We can check bits one by one from right to left. Right to left because computers can easily access the last bit. So first we look at the last bit, we flip it and then add its value if needed. Add its value if it is a 1 after flipping. And then we remove that bit, that is we move one step towards the left. And then we repeat this until the end of the binary number. Now let us see how the code works. So first we initialize a condition. If n is equal to 0, we return 1. So it's a given integer is 0, we just return 1. Now we initialize two variables, result and position. Both of them are initialized to 0. And then we start a while loop while n is greater than 0. N greater than 0 here signifies till the leftmost bit. And then we initialize bit equals to n and 1. By using and, we are checking the last bit of n, because 1, that is 0, 0, 0, 1 only overlaps with the rightmost bit. So if the current bit is 0 now, if bit equal to 0, we add the value of the bit to the result. And so result plus equal to bracket of 1 lesser than position. Why lesser than position? It means to power the position. It represents the value of that bit in binary. And then we exit the if n shift n, that is n is equal to n greater than 1. We are shifting it to 1 bit towards the left side. And then we are incrementing position by 1, position plus equal to 1. And then finally, out of the while loop, we are returning result. So the time complexity for this particular code is O of log n, because algorithm processes the number bit by bit and each iteration of the loop shifts the bit to 1. This removes 1 bit from the number. So a number has approximately log n base 2. So the loop runs log n times. So the time complexity of O of log n, because we process each bit once. And the space complexity is constant because there are only a few variables. So that's all for today. Hope you guys enjoyed today's video. See you in the next one. Bye guys.